right, we're moving forward. I think we're going to add 2 more days to our compound unit. Today and 1 more day. So actually it's just 2 days left. Today we're continuing our topic of compound inequalities. We're going to be dealing with solving and writing compounds today. That's what we're working on, solving and writing. So, we're extending. Yesterday you solved, but you didn't have to deal with any fractions. Today you're going to solve, you're going to have to deal with fractions. There's a little trick with fractions that can really help, and that is to get rid of the denominator. I want to remind you that fractions really represent a quotient. A quotient means divide. So to get rid of a denominator, you multiply through by whatever the denominator is. So when I say get rid of denominator, how do you do it is by multiplying. You can't read mine very good. Make it nicer. I'm going to erase this and make it nicer for me to read. But how you get rid of a denominator is by multiplying through. And then you will solve. You only get rid of the denominator when all you have left is a fraction. That's it. You only get rid of the denom when all you have left is a fraction. It's always kind of the last thing you do. You move what's not connected to it first. And you'll see that as we do some. All right, we're going to do some OR examples. 2/3 x is less than 2. Well, I guess I could go through and do the recip here. You're definitely welcome to. But there's a little trick that makes life a lot easier by getting rid of that denominator. Because what happens, if you multiply both sides by the denominator, it cancels it out. And I'm left with a whole number. 2x is less than 6. X is less than 3. That's a little trick. Instead of multiplying through by the reciprocal, you can first multiply both sides by that denominator, and it gets rid of it. The other one, the denominator is 4, so I'm going to multiply both sides by 4. It cancels it out. I'm left with the top. The top was 3x. 3x is bigger than 6. Just kidding, 24. X is bigger than 8, and this is an OR. Okay, so again, usually you're welcome to do the reciprocal, but it just kind of makes things, it can really stress some kids out. So the other little trick is to multiply through by that denom right away. All right, moving to the AND statement. I'm going to move to the AND one next. I have -3 is less than 3x over 5, which is less than 2. I don't want to multiply both sides by the reciprocal because I feel like I would get really stressed out over it. So I'm going to use my trick by timesing everything by 5, maintaining that algebra balance that we need. 5 times -3 is a -15 is less than, the 5's cancel, 3x, which is less than 10. Now I divide everything through by 3. Divide by 3. Maintaining balance, I have to do it to everything. -5 is less than x, which is less than 10/3. 10/3 is 3 1/3, which is 3.3 repeat. All right, now we're going to bump up the rigor. You do not get rid of the denominator first here on this example, this next example. You do not get rid of that denom first. Do you know why you don't get rid of that denominator first? Because I don't only have a fraction left. I have x over 1 divided by 3 plus 2 is less than 0. You can only multiply through when all you have is a fraction. So the first thing I need to do is get rid of that 2. That's the first thing I need to do. You will not get the right answer if you multiply by 3 first. So I have x minus 1 over 3 is less than negative 2. Can I get rid of my denominator now? Yes, because all I have left is that fraction. All I have left is that fraction, so now I can get rid of the denom. Times through by it. It cancels the denominator out. X minus 1 is less than negative 6. Add 1. X is less than negative 5. That's one part of my OR. Okay, the next part of my OR, see, this is what I mean by compounds. You kind of get gypped because you're really doing 2 problems in one here. Okay? The other part, do I multiply through by 4 right away? Yes or no? No. Why do I not multiply through by 4? Have to get rid of that 5 first. Absolutely. So I'm going to add 5 to both sides of the inequality. And I get x plus 2 over 4 is bigger than 6. Can I multiply through by the denominator now? Yes or no? Yes, because all I have left is a fraction. Once all I have left is a fraction, you can multiply through by the denominator. It cancels out the 4. I get x plus 2 is bigger than 24. Subtract 2. X is bigger than 22. This was an OR statement. Okay. The and example. Can I get rid of the denominator right now? Do I multiply through by 4 right now? No. What do I need to get rid of first? The 3. How do I get rid of the 3? Add it. Add it to how many sides? All sides. Plus 3, plus 3. So I got a lot going on here. 7 is less than, let's see, 2x minus 1 over 4, which is less than 9. Give you a minute to catch up here. I moved that 3 first because I want to get x alone, and you move the things that aren't connected to x first before you start moving the things that are connected. Now I go through and get rid of that denominator because all I have left is a fraction looking thing. So I multiply through by 4 to everything, maintaining the balance of algebra. 28 is less than, the 4's cancel, 2x minus 1, which is less than 36. I picked ugly numbers here. I see I'm going to have 2 fractions. It's okay though. Just trust your algebra. Add 1, add 1, add 1. Again, maintaining balance. 29 is less than 2x, which is less than 37. And now I'm going to half them. I got to divide everything by 2. Divide by 2. Divide by 2, divide by 2. And then I would just kind of leave it like that. 29 halves is less than x, which is less than 37 halves. Okay?